When I simplify exponential expressions, I have three basic steps that I follow, and you can see those on your notes page that you have in front of you. But those three steps are: step one, clear the parentheses. Once I do that, I want to make sure in step two that I change any negative exponents to positive exponents. And then for the final step, I simplify what I have using the product rule or the power rule or the quotient rule. So let's work these examples following those three steps. Step one, clear the parentheses. Well, in my example of a to the negative fourth, b to the negative 3, I don't have any parentheses, so I can immediately go to step two. And in step two, I think the reciprocal. I think reciprocal because I'm changing negative exponents to positive exponents. So basically, that a to the negative 4 will go to the denominator, and once I flip it to the denominator, it becomes positive. The same thing with the b to the negative 3. If I move it to the numerator, it becomes positive. And then step three, simplify using the product rule, power rule, or quotient rule. I can't simplify this because my bases are different. My base in the top is a b and my base in the bottom is an a, and they are not the same variable. So this would be my final answer. In example number 8, I'm following those exact same steps again. We have x to the negative 1 over x to the negative 4. And our first step is to clear the parentheses, but we do not see any parentheses, and then we go to that second step where we change those negative exponents to positive exponents. Well, remember, we're thinking reciprocal, which means to sort of flip it. That x to the negative 1 will become x to the positive 1 if we use the reciprocal and move it to the denominator. And the x to the negative 4 would become x to the positive 4 if we think reciprocal and move it to the numerator. So now I can go to that third step of using the power rule, quotient rule, or the product rule. And this is a quotient rule to where if we have the same base and we're dividing them, we keep that base and subtract our exponent. So 4 minus 1 is x cubed. And that's our final answer. In example 9, we have y to the power of negative 4 divided by y to the power of 6. And that first step is to clear parentheses, but again, with this example, we don't see parentheses. So we move to step 2, which says get rid of the negative exponents. Well, if you'll notice, y to the 6th is positive. We don't do anything to it. We leave it right where it's at. But the y to the 4th, y to the negative 4th is the only exponent that is negative, so it's the only one that we have to think reciprocal with. So we move it to the denominator, and it's y to the positive 4th now. And again, we leave that 6 in the denominator because it was already positive. Now what's up top? Well, I wrote this 1 up here beside it because we have an understood 1, y to the negative 4. That's what we started out with. So that 1 is the only thing that remains. We've completed step 2 and we're moving to step 3, which says to simplify using the 3 rules. And in that denominator, I can use the product rule because I have the same base and they're multiplied. So same base, add those exponents. And 1 over y to the 10th is the final answer. In example 10, we have a to the negative 4th, b to the 7th, and the whole thing is raised to the negative 5 power. So with simplifying the exponential expressions, our first step is to clear the parentheses. And this is the first example that, in a few examples, that we're actually getting to use that first step of clearing the parentheses. So when I have a variable to a power and it's raised to a power, I keep the variable and I multiply the exponents. So negative 4 and negative 5 give me positive 20. And the same thing, the same rule goes for the b to the 7th. It would be b to the power of 7 times negative 5, which is negative 35. So I get to go, once these parentheses are clear, go to step 2 and make any negative exponents positive. Well, I'm thinking reciprocal, and just for the fact of thinking reciprocal, I'm going to put that over a 1, and it will be more clear to me that the a to the 20th power stays in the numerator, but b to the negative 35th, well, that's a negative exponent. I want to change it to positive, and if I think reciprocal, the reciprocal of b to the negative 35th would be 1 over b to the positive 35th, so that b to the 35th becomes positive if I put it in the denominator. Let me fix that 20th power so that it looks more like a 2. Now we're moving to step 3, and it says to simplify using a product power quotient rule. But these two bases, a and b, are different variables. So a to the 20th power divided by b to the 35th would be our final answer. In example 11, I have x squared raised to the 3rd power divided by x to the 10th. So our first step is to clear the parentheses, and I just do that in the numerator. So if I have a variable to a power and the whole thing's raised to a power, I keep that base and I multiply those exponents together, and then for my denominator I don't have to do anything at all. And then I move to step 2, which says to get rid of any negative exponents, but I don't have any. So I can move immediately to step 3 and use one of my rules to simplify the expression even further. And I'm going to use the quotient rule. And since I have the same base, I'm going to subtract the exponents when they're divided. And so that would be a 6 minus a 10, which would be just x to the negative 4. But no, I don't want negative exponents. So I would want to write my final answer as at 1 over x to the positive 4. Now I could have not really written out, let's see, I could have not written out this step and just said that that 4 would immediately go to the denominator because 10 is bigger than 6. But if it's not clear to you, I suggest, doing the quotient rule exactly and saying 6 minus 10 is negative 4, and then move that negative and make it a positive exponent by using the reciprocal. So 1 over x to the positive 4 would be our final answer. In example number 12, we have a to the 5th b divided by a to the 7th b to the negative 2, and the whole thing is raised to the negative 3 power. So this one's really sort of exciting because we get to use, more than likely we're going to be using all 3 steps here. So starting off with step 1, clear the parentheses. So I'm going to raise each of these bases to the power of negative 3. So if I have a to the 5th and then raise it to the power of negative 3, I keep that base and multiply those exponents. So this becomes negative 15. A to the negative 15, b will be to the negative 3 power. Divide that by a to the 7th times, a to the 7th raised to the negative 3 power. I keep that a and say 7 times negative 3 is negative 21. And then b to the negative 2 to the negative 3 power will be b to the positive 6. So I move to step 2 and say that I want to get rid of my negative exponents. So let's start with the numerator. We're thinking reciprocal, and if I have a to the negative 15, I can move it to the denominator and it becomes positive. If I have b to the negative 3, I can move it to the denominator and it becomes positive. So now let's look at the denominator. If I have a to the negative 21, I can move it to the numerator and it becomes positive. But b to the 6th was already positive, so I put it back in the denominator. All of my exponents are now positive, so I can I'm actually going to use a product rule and a quotient rule to simplify the expression even further. If I look right here at a to the 21st divided by a to the 15th, I can keep that base and subtract the exponents. So 21 minus 15 is 6, so I get an a to the positive 6th power. And then b cubed times b to the 6th, since it's the same base, I can add those exponents, and it will be b to the 9th. Why is it in the denominator? Because both of these were in the denominator. So a to the 6th divided by b to the 9th would be our final answer. In example 13, we have 5x cubed y to the negative 2 squared. And our first step is to get rid of the parentheses. So let's see, the 5 gets squared, everything inside gets squared. The 5 gets squared, the x cubed is squared, and the y to the negative 2 is squared. So 5 squared is just 25. But when we have a variable that's raised to a power and then we raise it to another power, we keep that variable and we multiply those exponents to get the 6th power. And then y becomes negative 4 to the power of negative 4, because negative 2 times 2 is negative 4. And we can think of this as over 1 and move to step 2 where we change any negative exponents to positive. So the 25 is in the numerator and the x to the 6th stays in the numerator. But because y was to a negative power, we move it to the denominator and make that power positive, and we're all good. So 25x to the 6th over y to the positive 4 is our final answer.